So when we were talking about atoms, we talked about Dalton, who came up with the first concept that atoms are indivisible, and then we talked about the subatomic particles, which involve electrons, which Thomson discovered, protons in the nucleus, which Rutherford discovered, neutrons, which Chadwick discovered, and then we came up with this model, Bohr's model of the atom, which told us that electrons orbit around the nucleus at very specific energy levels. And up until this point, we've assumed, okay, that's fine, that's correct, but just like all the other models, this actually is not correct. And instead, electrons do not orbit around the nucleus. And instead, what they do is they are positioned in regions where they are most likely going to be found. So for example, for this S sublevel, which I'll talk about in just one second, there is the highest probability of finding electrons within this region. We're not saying they're orbiting around the nucleus. Within this shape, though, as you can see right here, that's where they're most likely going to be found. For P, for example, they're most likely going to be found in this dumbbell shape, so either along the x-axis, along the y-axis, or the z-axis, and this is actually what this sublevel looks like. So the green is where they're most likely going to be found. D gets even crazier with shapes, and then F I don't even show you. So these letters are your sublevels, and orbitals, the official definition, is the 3D volume where electrons are most likely to be found. So I'll write that out for you. So the 3D volume where electrons are most likely to be found. So as you can see, if it's this S sublevel, they're going to be within this region. That's where they're most likely going to be found. So we can't actually, we're not talking about electrons orbiting anymore. We're going to simply be talking about the 3D area where we're most likely to find them. And so what we're going to do is put this into a context that we understand by using the periodic table in order to describe how electrons are organized for an atom. We call this organization of the electrons around an atom, we call it the electron configuration. That's going to tell us how the electrons are actually organized around the atom. And so what we need to do is we need to use the periodic table in order to write the electron configuration. So I'm going to get this started. This section right here, which I'm highlighting in blue, and I would recommend that you highlight as well. This is your S block. Okay, remember S is a sublevel with this spherical shape. So this is your S block, and I promise this will make sense in a little bit. Okay, this right here, so don't include helium right there. This is your P block. Okay, in the center for your transition metals. This is your D block, okay? And then at the very bottom, for your inner transition metals, this is your F block. Now keep in mind, helium should be S, okay? So the way that we write out the electron configuration, it's like reading a book. So I'm gonna move from top to bottom, left to right. So this first row right here, this represents my first energy level, so N equals 1. The second row, N equals 2. So my second principal energy level, then my third principal energy level, then my fourth, etc., etc. Okay? So the way that I'm going to write this, you first write your principal energy level, 1, then you write your sublevel, which is S, and then you're going to write how many electrons there are. So I've only hit one box so far, so there's only one electron. If I move over here, because I'm reading it like a book, I'm still in my first energy level, S sublevel, but now I have 2 electrons because this is my second box. Okay. Now I'm going to move down to the second energy level, so it's going to be 2s, and I'm going to be filling in the first electron for this energy level with this subshell. Okay. Then I'm going to put 2s2 here. Okay. Then this is going to be 3s1 and 3s2. Okay, so pause me for a second and fill in the rest of this. Alright, now I'm going to move over to P. When I start here, notice there is no 1p. You start with 2 because I'm in the second principal energy level. So it's going to be 2p. Well, this is my first electron in that subshell. So 2p1, and this will be 2p2, 2p3, 2p4, 2p5, and finally 2p6. In the next energy level, 3p1, 3p2, etc., etc. So keep doing that and fill in the rest of this. Pause me, please. Now I need to do the D sublevel. So you would expect this to be 4 right here because you're in the 4th energy level, principal energy level, but it actually starts as 3D1. Then everything else is the same. So 3D1, 3D2, all the way to 3D10. Okay? And then this would be 4D1. Okay, and then you can fill in the rest. So there's your D's. Notice that you've got 2 that are missing right here, and so where those went, they actually went down below. And these involve, the reason why they're down there, they involve exceptions that we're honestly not going to address. However, that would be then 5D1, and this would be 6D1, and then the rest of them are going to be F's. Now, just as D started 1 below what you would expect this to be 5F1, because this is the 5th energy level, but instead it's going to be 4F1, which means this is going to be 5F1, okay, all the way to 14, so fill that in as well. So now that we've written all of this out, let's actually write the electron configuration for an atom. So the example problem that I give you in your notes is phosphorus. Okay, and so what I'm going to do first is I'm going to locate phosphorus. So phosphorus is actually, if I look at my periodic table and I put it in here, it is going to be right here. Okay, and so to write the electron configuration of phosphorus, I start at the very top, and I'm going to read until I hit 3p3. So I've got 1s2 because I've got these 2. So I'm not going to write 1s1, 1s1, 1s2, 2s1, 2s2 because if I'm at 1s2 that implies I've already passed by 1s1. So I'm going to just write 1s2. Okay. Then I've got 2s2. Then I've got 2p all the way to 6, so 2p6. Okay. Then I've got 3s2. And then I go all the way until I hit 3p3. And that is the electron configuration of phosphorus.